Good day, everyone. Today I will report the design of power screw, and my name is Henson Montealto. Power screw, which are also known as lead screw, are used to convert rotary motion into linear movement with suitable size thread. They are capable of large mechanical advantage and can lift or move large load. Application include screw jacks and traverses in production machines, although suited to fasteners thread form such as isometric standard screw thread. Slide. This is the definition of the designs of power screw. The next is the component, which is the nuts, bolts, bolts, screw with threaded cylinder and various type of heads. They are nearly always paired with a nut which has matching threaded hole. Nuts consist of square or hexagonal block, usually of metal. And next is the thread, the screw, and the rivet. In screw, a year shape is with spiral, groove, and slotted of reset head designed to be inserted into material by rotating. Uh, while the rivet, used to join two or more objects together permanently, it consists a cylindrical shaft with a head on one end and a tail on the other end. The tail of the rivet is placed through a hole in the object to be joined and then flattened or bucked on the other side. Slide. Uh, we have three types of thread. In square thread can be used to transmit power in either direction. Square thread have maximum efficiency and there is no radial or bursting pressure on the nut, increasing the life of the nut and making its motion uniform. But it is difficult to manufacture square thread because these are difficult to cut with cups and dice and and only usually cut on a latte with a single point cutting tool. Acme thread. Acme thread or the trapezoidal thread is used for power transmission. It has a higher load carrying capacity in comparison to square thread because of large root thickness. Acme thread are manufactured on milling machine using a multiple point cutting tool and are therefore economical to cut due to the slope provided on its sides. Efficiency of Acme thread is less than the square thread, and the nut is subjected to radial of bursting pressure. Next is the buttress, and the buttress is designed to take large loads in one direction. This is the strongest of the threads formed due to greater root thickness. Its efficiency is comparable with square thread, is easier to cut, and it's compatible with the split nut, and also find its application in light jack, screw, and vices. Next, this is the terminology of the power screw, the pitch, lead, nominal diameter, and core diameter, helix angle. Here in pitch, the defined as the distance measured parallel to the axis of the screw form a point of one thread to corresponding point on the adjacent thread. And the length is the defined as distance measured parallel to the axis of the screw, which is the nut will advance in the revolution of the screw. In the screw. Next slide is the problem. Uh, this is the problem, and we need to solve this. A square thread power screw has a major diameter of 32 millimeter and a pitch of 4 millimeter with double thread, and in, it is to be used in an application similar to that figure below. Applicable data are thread and color coefficient of friction equals to 0.08 color diameter of 40 mm and a load of 6.4 kN per screw. the determined, and we will discuss it later. Uh, we start on letter A. From the square thread figure above, it can be seen the thread depth and width are the same and equal to half the pitch or 2 mm. D sub m equals to d minus p over 2 equal 32 minus 4 over 2 equals 30 mm. D sub r is equals to d minus p equals 32 minus 4 equals 28 mm, while 1 equals np equals 2 times 4 equals to 8 mm. And in letter B, for square thread, the torque required to raise the load, and this is the one of the problem solving. We just copy the formula and solve it. T sub r is equals to ft sub m over 12, open close parenthesis, 1 plus pi, and that the d sub m equals to pi g sub m, and that's it, the problem. The R final as 0.5. Thank you. Okay na kaya, Toby?